Oh, that was a little abrupt, wasn't it? Sorry about that. Let's get back to what I was saying. So, we were talking about how if we were making a decision about what's more likely that the person that we've seen in the weight room is a football player who's an honor student or just an honor student, I was pointing out that this little small wedge, which is the overlap between the two fields of membership, would be a football player who is an honor student. Now, like I said before, this is not drawn to scale, so I'm not trying to imply anything by my circle sizes. I'm just trying to say that there will be, by definition, fewer people in that little wedge place where the two circles overlap than there is in this giant circle of all the honor students at the university. So statistically, we would be more likely to be correct if we just assumed that the person is one thing, in this case, an honor student, than that he is the confluence of two things, a football player who's an honor student. So we just would be more right if we say that he's one thing. But what we tend to do when we're making judgments is we ignore the probabilities and we say, I'm sorry, that person represents my prototype for football players too closely. I'm sorry, I'm going to go with football player, and I guess he could be an honor student also. So I'm pretty confident he's a football player because he looks like a football player. He's doing what I expect a football player to be doing, things like that. So the representativeness heuristic can cause us to focus on the wrong things. If the event in front of us matches our prototype or our expectations, we will accept it as a member of our category, even when it doesn't statistically make sense. Part of the reason why we make this error is because we so often are correct when we make this error. I mean, in those cases, it's not an error. In fact, in that photograph that I showed you, that person actually was a football player for Eastern at the time that I made that slide. So the fact that we so often are correct makes us say, well, is it really an error? The fact that we so often don't know when we're wrong when we make these judgments makes it more likely that we'll continue to use these rubrics in the future, right? These kinds of heuristics in the future. So we make these mistakes, ignoring probabilities, because we hardly ever get punished for it, right? We might be correct, or we may never even know that we were wrong. But it can lead us into sort of stereotyped thinking and cause us to make judgments that are ignoring individual differences and ignoring probabilities. A related issue is illustrated by this paragraph. Dr. Swinkle's cousin Rudy is a bit on the peculiar side. He has unusual tastes in movies and art. He is married to a performer, and he has tattoos on various parts of his body. In his spare time, Rudy takes yoga classes and likes to collect old 78 RPM records. An outgoing and rather boisterous person, he has been known to act on a dare on more than one occasion. What do you think Rudy's occupation most likely is? And you get to pick from this array. Farmer, librarian, trapeze artist, lawyer, or surgeon. All right, so you get to pick one of these careers. Now, of course, if you succumb to the representativeness heuristic, you might say, oh, well, he sounds like a trapeze artist. I'll say trapeze artist. But remember, the error with the representativeness heuristic is that you're ignoring the statistical probabilities. So let's try not to make that mistake. Let's think statistically. How many trapeze artists do you think there are in the world, or even in the U.S.? So maybe we can narrow it down. Probably not that many, right? How many farmers are there? More than trapeze artists, I'm going to guess. How many librarians? You know, I'm saying I'm going to guess. I could look this up on the internet and know, but I'm trying to do an illustration of what we do in our heads. We go, well, he sounds like a trapeze artist, so I'll make that mistake. But let's be honest, trapeze artist is probably the lowest frequency career of all the careers I placed here, right? It's much more likely that a person would be a farmer than a trapeze artist. I don't know. Farmer and librarian might be roughly equivalent. There might be more farmers than the librarians. I'm not sure. There are definitely way more lawyers, and there are definitely way more surgeons in the world than there are trapeze artists. What I'm trying to guide you through is to avoid the base rate fallacy. A lot of times we ignore how uncommon something is. We forget what the base rate of this event is in the population, and we get fixated. And ignoring those statistics, we can make some pretty big mistakes. So if we realize that the base rate of trapeze artists in the population is much lower than the base rate of lawyers, it doesn't matter what Rudy is like. We should just guess that he's more likely to be a lawyer than a trapeze artist. So if you put the representativeness heuristic, well, he sounds like a trapeze artist, together with our tendency to ignore base rates, we might make that mistake and say, well, I guess he's a trapeze artist, when the fact is we would be much more likely to be correct if we picked really any other career of those 5 than trapeze artist. So these two work hand in hand quite often in our thinking errors, but not always. Because, for example, I was just reading about a famous person who had a melanoma on her foot. And what caused her to notice that there was something wrong is that she noticed a little mole. And when she says that when she went to the doctor, he said that if you had waited even a couple of weeks, you would have had to have chemo and all sorts of other things. But in this case, we'll be able to do surgery to remove it. When you hear of a famous person who you know and they have something like that, I don't know about you guys, but first thing I start thinking is, do I have any new moles? Forgetting the base rate of melanoma in the population, it's really unusual. You should always check your moles. Don't be misinterpreting what I'm saying. But should we freak out and think every mark on our body is melanoma? Probably not, because the base rate of melanoma is pretty low, right? The probability that it's melanoma is much lower than the probability that it's a mole or a freckle. So when we're making judgments about illnesses or whether it would be dangerous to go to this city or that city, things like that, we oftentimes forget the base rate. Like, what's the likelihood that you would actually be the victim of a crime if you visited New York City, for example? The base rate of crime is actually a lot lower than you might think, because New York City might fit your representativeness heuristic for dangerous cities, right? But if you check the crime statistics, you might realize, well, actually, it's not that bad. It's the probability that something bad would happen to you is pretty low, because the base rate of bad things happening to people is pretty low. So those thinking errors can go together, representativeness and base rate, or they could work independently. But what they do is they cause us to over or underestimate the likelihood of things. Okay, so I think I am back to where I had accidentally cut something off. So I will let you continue with the next video from here.